All right, guys, so congratulations on completing your CPT. I will probably have the mark hopefully before the end of the week, so hopefully all by Wednesday. That way I can give you guys a final mark to base off so you guys know what your final mark is. Other than that, thank you for handing it in on time. You guys have been awesome. I've had no problems with you guys handing stuff in on time. So that is kudos to you guys, okay? So this last unit, although I'm not going to assess it, you guys are going to have to learn it for next semester anyway, so might as well give you a jump start on it. So you're going to be learning about determining the average rate of change for lesson 8.1. Okay, so average rate of change, obviously, we've learned this through grade 9, 10, and 11. It's just finding the slope of a line. Okay, so remember when two quantities are related in some way, they form a relation. In a relation, the variable that depends on the other variable is the dependent variable, and the variable that does not depend on the other is independent. So time is independent. And then we have cost is dependent because that depends on the time. So in a vertical table of values, the independent variable is placed on the left and the dependent is on the right. So in a horizontal table of values, the independent is placed on the top and the dependent is placed on the bottom. And then we have in the graph, obviously you guys know, independent goes on the x-axis and dependent goes on the y-axis. So when the graph of the relation is a straight line, the relationship is called linear. When the graph of the relation is not a straight line, the relationship is called nonlinear. So again, these are stuff that you guys learned in grade 9, 10, and 11. So the slope of the line is the inclination or steepness of the line. So m is equal to delta y over delta x, or what you guys learned is y2 minus y1 over x2 minus x1. And some of you may have seen this already, some of you may have not. So we have a secant line is a line that passes through 2 points on the graph of a relation. So we can have a point over here and a point over here. And if we draw a line, this is called the secant, okay? So that is what a secant line is. It's going through 2 points in a graph that is non-linear. So now we're going to get into some examples. So we have the average rate of change is a change of quantity given by the dependent variable y divided by the change in the independent variable, which is x, over a certain interval. So we have the following table represents the growth of the bacteria over a 10-hour period. We have time as our independent, and we have number of bacteria as our dependent variable. So during which 2-hour interval was the bacteria population growing the fastest? We're going to use a chart to help us solve this answer, okay? So we have between the interval of t is in between 0 and 2. So obviously the change in time is going to be 2 hours. And as you can see, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. All of these changes are going to be 2, okay? So now the first one, delta B, we need to find the change in the number of bacteria. So we're going to take f at 2 minus f at 0 and divide that by 2. Well, not divided by 2 yet because that is what we would have to do at the end. So to find the change, we just do f at 2 minus f at 0, which is equal to 1022 minus 850, which gives us 272, okay? So that is our delta B. So now to find the last column, we do delta B over delta T, which is equal to 272 divided by 2, which gives us a total of 136 bacteria per hour. And you're going to be doing the same thing for each of the other ones. So the next one T is between 2 and 4. We do f at 4 minus f at 2. So f at 4 hours is 1,481. And f at 2 was 1,122, which gives us a change of 359. And then we continue with the next ones. So we get a change of 473, 623, and 823. So as you can see, each change in the number of bacteria, the more we go to the higher intervals, gets greater. So we can assume that this is going to be close to an exponential function if we were to graph it out. So now we just have to figure out the rates of change for the rest of them. So the rate of change for t is between 2 and 4 is 179.5. Then we have 236.5. Then we have 311.5. And finally 411.5. So what can we conclude from this? So we can conclude that the greatest change happened in the last interval, okay? So the greatest change happened in the last interval, which was t is greater than 8 but less than or equal to 10. And now we want to reflect on this whole problem. So why is the average rate of change of the bacterial population positive on each interval, and what does this mean? So the average rate of change of the bacteria is positive because the rate of change gives us positive, okay? It gives us a positive number. Which means that the bacterial population is increasing over time. Which is true, because if we were to keep extending, it would be safe to assume that the number of bacteria grown after 10 hours would be greater than the bacteria we had at 10 hours. Okay? So like I said, this is nothing new. We're just learning the rates of change you guys learned from grade 9, 10, and 11. So here we have the graph. Like I said, this is an exponential function. Since the number of bacteria kept growing exponentially more as time went along, okay? So for the graphing example, we want to draw a secant between t is equal to 6 and t is equal to 8, and we want to calculate its slope. So t is equal to 6, t is equal to 8, and we want to draw a secant, okay? And now we want to find the slope of the secant. So all we're doing is using basic stuff we learned from grade 9, 10, and 11. So m of secant is equal to y2 minus y1 over x2 minus x1. So we know this is our point 6 and 1954. And this point is 8 and 2,577. Okay, so our y2 is 2,577, and our y1 is 1954. Our x2 is 8, and our x1 is 6. So when we simplify this, we get the slope of the secant to be 311.5. Which is what we found using the chart. So this is the same as the chart, except we just used a visual to calculate the slope of the secant in this case, okay? And then we want to draw a secant for the pair of points in each 2-hour interval from the graph, which secant has the greatest slope. So if we reflect from what we wrote in question in the previous example, we said as the intervals get bigger, the rate of change gets bigger. So it would be safe to say that the biggest rate of change would occur from 8 to 10. Which was 411.5, okay? So the secant line that has the greatest slope is t is greater than 8, but less than or equal to 10. And that is just based off what we found from the charts and based off what we found visually when we made the secant line. And connecting, so how are the average rate of change for various intervals represented on the graph? These changes are represented by secants. So hopefully everyone's good so far. Like I said, there's nothing really new. We're just taking it easy for today. This is just the first lesson, so of course it's not going to be too difficult. So example 2, we have a taxi driver charges a base fee of $125 plus 75 cents per kilometer. The equation CD is equal to 0.75D plus 1.25 can be used to calculate the cost of using the taxi, where CD represents the total cost in dollars and D represents the distance driven in kilometers. So now we have to fill out the table of values on the right-hand side, and we need to calculate the average rate of change for the following distance intervals. So I'm just going to fill this out for you guys. So we get $1.25, $5, $8.75, $12.50, $16.25, and $20. So for question, the first interval, we want to find the rate of change between D is greater than or equal to 0, but less than or equal to 15. So the average rate of change, ARC, is equal to C of 15 minus C of 0 divided by 15 minus 0. And that gives us 1250 minus 125 divided by 15, which gives us 75 cents per kilometer, which makes sense because that is the rate of change given to us in the equation. So now that that's verified, we need to verify that it's the same thing for example 2. So between D is greater than or equal to 15, but less than or equal to 25. So you get ARC is equal to C of 25 minus C of 15 divided by 25 minus 15, which gives us 20 minus 1250 divided by 10, which gives us again 75 cents per kilometer, which means that this is in line with the equation that was given to us. So now we want to interpret the meaning of the values found in parts A, and we want to include the correct units for these values. So this represents the constant rate of change in dollars per kilometer. Okay, so that is what that represents. It represents the constant rate of change in dollars per kilometer. And how is the average rate of change represented on the graph? So it is represented through finding the slope. right? And we just have one more example. So like this lesson may have seemed long because it has 5 pages, but in reality, it's just simple things that we've learned from previous math courses and just applying it to rates of change in grade 12. And now we're going to go to our last example. So page 71, the volume of water draining in a hot tub. So this is from your textbook. We're going to calculate the average rate of change in volume during each time interval. So again, same thing. The ARC is equal to V of 40 minus V20 divided by 40 minus 20, which gives us 711 minus 1,111 divided by 20, which gives us negative 20 liters per minute, which means that from 40 minutes to 20 minutes, the bathtub is losing water during that time interval. So now if that's true, that means that from 110 to 120, the bathtub is also losing water during that time interval. So again, ARC is equal to volume at 120 minutes minus the volume at 110 minutes divided by 120 minus 110, which is equal to 0 minus 10 divided by 10, which is equal to negative 1 liter per minute. So what we can conclude from this is that you're losing most of the water at the beginning than opposed to the end, okay? Because the rate of change is greater at the beginning than it is at the end. So we want to ask ourselves, why is the rate of change in the volume negative during each of these intervals? This is because the volume of water is decreasing during time. And the last question is, does the hot tub drain at a constant rate? And based off our average rate of change, the answer is no. The average rate of change is always changing. Okay. So now we have the summary. We find the average rate of change of doing delta y over delta x, y2 minus y1 over x2 minus x1, or f of x2 minus f of x1 divided by x2 minus x1. Okay. So graphically, this is equivalent to the slope of the secant passing through 2 points, x1, y1, and x2, y2. So if the secant of the line has a positive slope, the average rate of change is positive, and the dependent variable is increasing on the specified interval. Okay, and then we can only take a educated guess on the second one. So if the secant has a negative slope, the average rate of change is negative, which means that the independent variable is decreasing on the specified interval. Okay, and the average rate of change is expressed using the units of the two quantities that are related to each other, and all linear relationships have a constant rate of change. Average rate of change calculations over different intervals and of the independent variable give the same result. If it's non-linear, they do not have a constant rate of change. The average rate of change changes over different time intervals. Okay, so that's it for lesson 8.1. Okay, we just talked about average rate of change and how different things change over time. If it's linear, it's constant. If it's non-linear, the average rate of changes are different. Okay, So remember, tomorrow you have your Unit 7 quiz. And like I said, I'm going to try to get your CPTs marked as soon as possible. But other than that, that's pretty much it for this lesson. And hopefully you guys can take a breather this week and not have to worry about assessments or assignments after tomorrow.